Hi class, so welcome to this video. No, we're going to leave out now yung uh, method of consistent deformation, and we'll start moving to three-moment equations. No, so for three-moment equations, I'm going to upload three videos. No, based on the assessment na uh, I want the videos to be as short as possible. No, I divided it into three parts instead of uploading one video kasi matatagalan tayo. No, and also uh, for just to again, no, yung mga later topics natin, no, we're going to focus on uh, multiple degree, no, indeterminate beams, no, and frames, no. So we're going to leave out now yung mga single degree of uh, single degree indeterminate structures, no. Kasi although yung mga susunod naman nating technique can solve those type of problems, no? Of course, mas maikli na yung mga magiging solution natin compared to before, no? And itong starting three moment equations, no? We can solve, no? Uh, we can solve we can solve as many support as possible, no. So kahit gaano pa karami yung kahit pa gaano kataas yung degree of static indeterminacy natin, mas masosolve na natin siya with uh, much more ease, no. And also, no, ang mga hahanapin na natin, no, yung in terms of paghahanap ng reaction, no, uh, our next techniques, no, will be focused on finding internal moments, no. So might as well you review, no, yung part ng method of consistent deformations na nag-emphasize on internal forces or internal moment as redundant, no. So I'm going to let me discuss to you first, no, yung three moment equations. So what is three moment equations? No, three moment equation is another force method, no, another type of force method aside from the method of consistent deformation, no. It is developed initially by Clapeyron, no, during 1857, and it provides a convenient tool, no, in analyzing continuous beams, no. So why is it applicable to continuous beams, no? It determines the relation between the moments of any 3 points within a beam, no, and the relative vertical distances or deviation, no. So assuming that you have a simply supported beam here, no, any 3 points na nasa beam, no, you can be able to determine the moment, no. So pwedeng from the support, no, pwedeng from the supports and any point na nasa gitna ng any point from within support, no, or even let's say the points A, B, and C, which are all located inside the beam, no. So ayun, no, we can be able to determine, no, the relationship on the moments between these 3 points, no, with uh, their deflections, no. Okay, and next we're going to derive, no, a formula, no. So how are we going to derive the formula, no? This one, no. Again, we are to find, no, we are to consider a simply supported beam, and we're going to consider the points A, B, and C, no, within the beam, no, and subjected to any type of loading, no, and this will be the assuming na ito ang magiging itsura ng elastic curve niya, no, when subjected to load, no. So ang assuming ang pinaka ang isa pang assumption natin diyan, no, we assume that the middle point, no, let's say point B, no, is the lowest point, no, of the 3 points within the beam that we're going to determine, no. So therefore, no, dahil inassume natin na yung point B is the lowest part, no, we can form, no, a tangent line, no, starting from point B, no, upward going to point A, and then downward going to point C. Okay, no, so ito ang magiging itsura ng tangent niya from B, no. So this is your tangent from B, no, this is your tangent line. Okay, and then, no, if we draw an imaginary horizontal line there, no, this is how will it look like. And we are able to, no, from the principles that we've learned in area moment method, no, ang tangential deviation daw, no, of A, no, point A with respect to the tangent at B, no, is the distance, no, between, no, the tangent, the elastic curve, no, the elastic curve at point A and the tangent from point B, no. So therefore, no, ang tangential deviation natin is located, no, above the tangent line. But since we assume that point B is the lowest point, no, between the yung tatlong point na kino-consider natin, no, ang distance ng triangle na to is equal to h1, no. So h1 is the vertical distance of points A and B, no, when the beam is subjected to load, no. So therefore yung triangle natin dito, no, is h1 minus tangential deviation of A with respect to B, and ang length niya is equal to, the length pala from A to B is L1, ang length naman natin from B to C is L2. O nga pala again, no, dahil pababa naman ang tangent natin from B going to C, we can say that the tangential deviation of C with respect to B, no, is the greater value than your H2. So therefore, no, the height of the triangle naman is the tangential deviation of C with respect to B minus H2. Okay? And then using ratio and proportion of triangles, no, we are able to derive this formula, no, the h1 over minus tangential deviation of A with respect to B over L1 is equal to tangential deviation of C with respect to B minus H2 over L2. Ang H, then we combine the two tangential deviations and then the 2H. So we are able to derive this formula. Pero, how are we going to consider again how are we going to compute these two tangential deviations? No? So, paano natin kukumputin yung tangential deviations na to? No? Balik tayo sa figure. Going back to the figure. No? So, we're going back to the figure, no? So we only considered 3 points A, B, and C within the beam, no? And we're going to isolate, no, all the internal moments M sub A, M sub B, and M sub C, no? We're going to isolate the three internal moments, no? And ang matitira na lang will be, no, yung span AB and span BC, no, subjected to loads, no, and both spans are acting like simply supported beams, no. So paano nangyari yon, no? So balik tayo dito. If you can remember, no, we've discussed yung method of consistent deformation, and we also tried to use internal forces and moment as a redundant, no? So consider this continuous beam, no? We want to remove the moment here by applying an internal hinge, no? So we applied an internal hinge, and then we apply the internal moment separate from the original loads, no? And when we apply the internal moment from the original load, no, pwede nating paghiwalayin yung mga span na parang mga simply supported beam lang. Okay? Ganon din yung ginawa natin dito, no? So yung tatlong point na to, no, so may A, B at saka BC, no, na we assume are both simply supported, no? So A, B, BC, no, in-assume natin na ang moment diagram niya is like this, the moment diagram is also like this. Pero of course, no, we separately applied the internal moments, no. This is your AB, M sub A rather, and this is your M sub B. M sub B, M sub C. And we also assume that the moment diagram of the internal moments that we neglected is this one, no? Triangular siya, no? Kasi inassume lang natin na constant yung MA and constant yung MB. There are no other loads that are acting on it. We assume that MB is constant, MC is also constant. There are no other loads acting on it. Okay? No? So, by going back here, no, we can be able to compute for the tangential deviation of A with respect to B equal to 1 over EI, no, multiplied by A1, no, multiplied by A, no. So this, ito yon, no. So the moment diagram, no, when we assume it is a simply supported beam, no, and ang centroid will be measured from point A, no. So centroid natin manggagaling sa A. So ito yon, A1 times A plus 1/2, no. So this one naman tayo. So this is a trapezoidal shape, pero I decided to separate the right triangle from the rectangle, no? So ganito ang nangyari, 1/2 times m sub a minus m sub b, no, multiplied by L1, no, times L1 over 3, no, plus MB L1 times L1 over 2. And when we combine all of them, no, itong kalalabasan niya, no, so 1 over EI1, no, multiplied by A1 centroid A plus 1/6 MA L1 squared plus 1/3 MB L1 squared, no, quantity. Sa tangential deviation of C with respect to B naman, no, this is equal to A2, area 2, no, this is your area 2, multiplied by the centroid, no, measured from point C going to point B. So that is your B, no, A to B plus 1/2 times MC minus MB. So ito yon, no, same as what I did earlier, MC minus MB. So ang inassume ko pala, no, I decided to assume na your moment at A is greater than moment at B. M sub C is greater than moment at B, no? And don't worry about this assumption, no? We just did it for the sake of our discussion, no? So M sub C minus M sub B times L2 over 3 plus MB L2, no? Times L2 over 2. And if we combine all of them together, 1 over E2I2 is equal to A2B plus 1/6 MC L2 squared plus 1/3 MB L2 squared. No? So we already have our tangential deviations, no? So from the original equation, we are just going to divide them to L1 and to L2. So therefore, we will be able to have this one, H1 over L1 plus H2 over L2 is equal to 1 over E sub 1, I sub 1 multiplied by 1/6 MA L1 squared, no? O nga pala, no, don't forget, no, I already divided your tangential deviations with respect to L sub 1 and L sub 2. No? So E1, I1, L1, E2, I2, L2. Okay, so 1 over EI, no, 1 over E sub 1, I sub 1, no, 1/6 MAL1 plus 1/3 M sub B L sub L1 plus 1 over E2 I2 times 1/6 M sub C L2 plus 1/3 M sub B L2, no, plus the first moment of area of A, no, with respect to A over E sub 1, I sub 1, L sub 1 plus A2 multiplied B. This is the the first moment of area 2 over E2, I2, L2. We can rearrange that, no, by this one, no? So M sub A multiplied by L1 over E1 I1 plus 2MB L2 over E2 I sub 2 plus L1 over E1 I sub 1 plus MC times L2 over E2 I2 plus 6A1A, no? So this is the first moment of area of the first span, no, over L1 E1 I1 plus 6A2B, the first moment of area of your second span, no, with respect to point C over L2 E2 I2, no, is equal to 6 multiplied by H1 over L1 plus H2 over L2. So this will become your general formula for three moment equations, no? So we assume that the EI the EI of your first span, yung AB, span AB nyo, and yung span BC nyo are different. What if your E is constant? No? If E is constant, okay? If E is constant, no? MA times L1 over I1 plus 2MB over L1 over I1 plus L2 over I2 plus MC times L2 over I2 plus 6A sub 1A over I1 L1 plus 6A2B over I2 L2 is equal to 6E multiplied by H1 over L1 plus H2 over L2. That is your formula if E is constant. But what if your EI, both E and your I is constant? No? EI is constant. Okay? So, we just assume that I1 and I2 is equal. No? So, MA L1 plus 2MB times L1 plus L2, no, plus MC L2 plus 6A1A over L1 plus 6A2B over L2 is equal to 6EI times H1 over L1 plus H2 over L2. Okay? Those are your typical formulas for three-moment equation. No? So, you can post this if you want to write it down. No? Okay? So, I'm going to show you also how are we going to apply, no, this formula, no, when we're about to solve for support reactions, no. So here are the usual situations that you might encounter, no, in the future, no. So you're given a continuous beam, no, all ends are both ends A and D are simply supported, no. And second situation, let's say A, B, C, and D, no, are somewhat the same, no, but points A and D are fixed, no. So let's look at the first figure first, no. We can be able to use, no, the three moment equations, no. So magpo-pertain tayo, no, na dahil meron tayong apat na support, no, we have four different supports, no. We will choose three of them to form one equation, no? So assuming natin na m sub a, m sub b, and m sub c, that is one equation, no? So b, c, and d, no, it is another equation, no? Pero you have to take note that points a and d are both simply supported, no? So we can say na m sub a, no, pag ginamit natin yung general yung formula, no, m sub a, no, tsaka m sub d is 0, no? So m sub a, m sub d is both 0. Okay? And we have values for moments at B and point C. Okay? No? So, and in solving for the reactions, no, we will assume first na every span are simply supported by installing an internal hinge here. Hinge. Huh? And another internal hinge. Okay? No, so assume na simply supported muna, assume na simply supported, no, assume na simply supported. And then when we already have the moment, the internal moment that we need to solve, no, we will determine the reaction due to the internal moment that we have already solved. Okay? No? So next situation, no, we can also do the same, no, if ends A and D are both fixed. Pero we have to you have to realize, no, na we really cannot apply internal hinge here. We really cannot totally eliminate the moment, no? So therefore, we are going to convert it into an imaginary continuous beam with simple support at both ends, no? So pagka fix ito applicable lang kapag fix yung support mo. Okay? So sa A, lalagay tayo ng imaginary support, ng imaginary span. Let's say this will become your A prime, no? So ang length niya is equal to 0. No, sa D, maglalagay din tayo ng imaginary na support, no? This will become D prime, the length is also 0. So pwede nyong gawin, no, sa 3 moment equation, A prime, A prime, A, B. So this is one equation, no? So C, D, D prime, this is another equation, no? Tapos you can also say A, B, C, B, C, D, no? It depends on you, no? Pero much better, we're going to try solving problems concerning 3 moment equations, no? It for this video, no, concerning the derivation and some concepts concerning 3 moment equation. On the next 2 videos, we're going to solve 2 different problems, no? And for any questions, you continue to don't hesitate, no, to either leave your comments below or just message me, no? And to be updated of the announcements, no, always check your Blackboard, no, or like and subscribe to this channel, no. Thank you very much.